This morning we're going to get started using Smalltalk, and what I'm going to try to introduce is if you pick one of the Smalltalks, the one we're going to work with here is Pharaoh. The question a lot of people come up with is, what do I do next? Well, I've downloaded Pharaoh, I've got my one-click image, so I double-click on it, and now I'm presented with a bare screen. What do? I can start clicking the mouse around and get menus, but that's not that meaningful to me as a new user. Pharaoh makes things a little easier though. You come in here to this window, if you read this, which to be honest I didn't, you'll notice that there's a getting started tool right built into this called ProfStef. If you do go on this, and the way you do that is to right click and you get this menu and just pick do it, and you'll get a lesson browser basically. Notice it says that you're in lesson 1 of 24, the welcome, and to proceed, it's not a button, it's trying to teach you how the environment works. So you highlight the code, you right click, and you select do it, and that'll give you another window. Now from here you say, well, what do? Well, it explains how Smalltalk works a little bit. It tells you that you can highlight things and either hit Command D if you're on a Mac or Control D if you're on Windows. So if I want to see a browser, I highlight Browser Open and do it. And that'll give me a Smalltalk browser. Now if you're a beginner, this doesn't mean much to you again, but again, you've done something and you can see how you get to that stuff. Also, you can get some information on the system. You do it here, and it'll tell you how the system is set up and what's going on. So that's some basics on this, and then you can go on to the next lesson. And I think at this point you get the idea. I do it here. And what I would suggest is you walk through this. What I'm going to do in the next screencast I cover is go through some of these expressions and start trying to cover Smalltalk syntax with you. But if you just want kind of an interactive walkthrough that shows you how to get started with a system like Pharaoh, walk through the ProfStef thing, do the instructions that it tells you to do, start getting a feel for the system. This morning we're going to continue in Pharaoh and get a basic idea for the initial syntax of Smalltalk and how things work. You've already understood, based on the last tutorial, how to get through doing Smalltalk expressions, making them operate, and I'm continuing to go through the ProfStef thing here in Pharaoh. First, let's take a look at numbers. So you have numbers are basic objects. It explains this up here, and you can highlight any expression like this, even just an object like 2, and do something simple like a print it. Now do it wouldn't do anything, but if I print it, notice it gives me back 2. The more interesting thing about that is that any object in Smalltalk can be inspected and operated on. So you can always ask an object about itself. And there I asked it to print a version of itself, and of course 2 just prints 2. Likewise, 20 factorial. How does that work? Well, if I do it, it's not going to do anything. Well, it's not going to visibly do anything, but it'll actually do the factorial. If I print it, on the other hand, it will give me the answer. So you can see how that operates. So you can see various messages that I can send to objects, and I'm not going to go through the message precedence right now, but just understand that I can send messages to objects like factorial to 1,000, the divide to the result of that, and then divide by the result of all of this. So here again I have parentheses. You might wonder, well, why do I have that? Well, it's just for visible representation here, although down here it's a little more crucial. Why do we have parents here? Well, this is because in Smalltalk there's no arithmetic precedence. In Smalltalk, there is a very simple set of precedence rules, and arithmetic precedence isn't part of it. So if you wanted to have the division happen before the plus, you have to put the parentheses in. And I'll get to precedence in a future screencast, but just keep in mind that arithmetic precedence is not part of the Smalltalk language. You can just go through this to get a basic idea for how things work, but in general what you should understand is that numbers are one of the fundamental Smalltalk objects, but they are objects. They're not some kind of primitive thing like they are in many other languages like Java or C#. They are actually objects in the system that respond just like everything else. This morning we're going to continue on past numbers to characters. Characters can be instantiated using the $, and like numbers, characters are literals in Smalltalk. You can instantiate them just by typing them in. So if I type this $a class and do a printed on it, you'll notice that it tells me that the class of that is character. And I can do things like send char code to it. I can send CR to the character class and get a carriage return. I can send space to the character class and get a space. And you can print all the characters in the simple ASCII set. So you can do a variety of things on class character, but the point here is that characters are literals like numbers. So let's go on past characters and go to the next one. We have strings. In Smalltalk, strings are designated with single quotes. So I have tick, text, tick. That's how I designate that this is a string object, and a string is nothing but a collection of characters. So I have my collection of literal characters, put them together in between tick marks, I have a string. So here if I do this, I can send messages like size to it, and I can find out how long it is. I can do things like this, ABC as uppercase, and you'll see that it does what I expect. It's going to give me back ABC in uppercase. And I can do a variety of other messages that you can try here. Notice that this @1, this is how I index into collections. Instead of the sort of square brace notation you'll see common in languages like C or things derived from C, in Smalltalk it's a message send like @:, and to put in it'd be @:put:. But the point here is that strings are handled by putting tick marks around things, and they're collections of literal characters. One more page we'll do on this topic today, and that is symbols. Symbols are kind of like strings, but they are unique in the system. So once I create something like ProfStef with a £sign in front of it, there will only be one instance of that in the entire system. It's unique, which makes it highly useful for things like dictionary lookups. If I want to have a dictionary of things and I want to have a unique keys, a symbol is a great thing to use. And the way I can tell that is this double equal message. Double equal will do a identity check for an object. So if I send 2 as string equal to 2 as string, the double equal, notice that this should come back as false because they're not the exact same object. Whereas if I create as string and then send as symbol to it, that should come back as true. And the reason for that is that there should only be one instance of that symbol in the system. Symbols are guaranteed to be unique in the system, whereas strings are going to be different objects that get instantiated. This morning we're going to take a look at literal arrays, or arrays in general. To create an array on the fly, you just type the $, parentheses, and then the objects space delimited. Now you can do this with literals. If you wanted to create an array of more complex objects, you need to actually do some object creation, which we'll get into in the future. But if you want an array of literal objects like numbers or strings or symbols, you can just toss them in like this. So pound, paren, the numbers. Pound, paren, the numbers, followed by another array. Notice how I've embedded 2 literals in here. Well, actually 4 literals. I've got 3 numbers and a literal array. Here I've got 3 literals. So I can put in this and say, is it empty? And I'll print it and it'll say it's false. I can ask this for its size. Notice that the size is going to come up as 4 because I've got 1, 2, 3 objects, 4 objects. This array itself has 3 objects, but in the outer array there are 4 things. So you can do these sorts of things, and if you want to insert things in here, I can say hello squeak @2 put Pharaoh. So at the second object put this. Now I will say one thing about this. Let's go ahead and print that, and it'll put in that. Notice that I've replaced the second element squeak with Pharaoh. This works in Pharaoh, this works in Squeak. This will not work in either VisualWorks or Object Studio because of immutability. So you need to be a little careful with the way some of these things cross Smalltalk. If I try to cover cross-platform or cross-dialect Smalltalk in the future, I'll go into more detail about this. But this kind of Smalltalk code is not safe for doing cross-dialect work. So keep that in mind. In any case, literal arrays, that's how you create them. This morning we're going to start taking a look at the message sending syntax of Smalltalk. We're going to start with the simplest ones, unary messages. In Smalltalk, the only way you can get anything to happen is to send a message to an object. There are 3 kinds of messages, unary, binary, and keyword. Basically, you can think of binary as syntactic sugar, and I'll get to that in a moment. Unary messages are just a message that takes no arguments and are sent to an object. So here I have the object 1, I'm sending it the message class. So if I do this and print the result, I should get the class that 1 belongs to, which is small integer. False not should give me what I expect, true. So I'm sending a message called not to the class, to the object false. Time now, notice the capital T, that tells me this is a class and I'm sending the now message to it. So I can do this. And this tells me something interesting. Classes in Smalltalk are full-blown objects. Everything in Smalltalk is an object, and the only way to interact with objects is to send messages to them. There's really no way around this. So these are all examples, including this tutorial example, ProfStef next. So that's just sending a unary message to the object ProfStef. Now, binary messages. These are what can be called syntactic sugar. Basically, everything that is an arithmetic style operator in most languages is a message send in Smalltalk sent to objects with this kind of special syntax with exactly 1 argument to make it look more normal. I guess the designers of Smalltalk decided the keyword messages would look a little funky if attached to things most people think of as operators. So you can send things like 3 times 2 and you'll get exactly the answer you expect. 6. Date today, unary, plus 3 weeks. This gets you into a little bit of precedence. Notice the way this is going to work. Date today plus 3 weeks. If I do this and do a print it, I should get 3 weeks from today. I execute the unary message first, this unary message second, and then the plus. So binary messages have lower precedence than unaries. Unaries will execute first, binary second. In general, you move from left to right. So here we have another binary. Here we have another binary. So you see the way these work. Here I'm going to get a point object 10 at 100. I'm going to get the point 10 at 100, as you might think, and that's just the way it prints. Here I have another binary. Notice binary messages can contain one or two symbols in the middle, followed by one argument. So that's the way binaries work. And again, comma is a binary. It's just for concatenating strings. So these are all examples of binary messages. And again, the basic precedence of these two message types is unary, binary, left to right, where unaries always execute before binaries. Now, if you wanted a binary message to execute ahead of a unary, what would you do? You'd have to use parentheses. And the reason that's important is something like this. I'll start typing here and show you what I mean. 4 plus 3 times 2. You would think this would be 6 plus 4 or 10, but in Smalltalk it's going to come out as 14. And the reason is, again, left to right, unary, binary, no arithmetic precedence. Something a lot of people have a little trouble getting used to, but it's something you need to realize in Smalltalk. This morning we're going to take a look at the last form of message sending in Smalltalk, and that is keyword messages. And this is a way of sending an arbitrary number of arguments to an object when you send a message. So for between colon 0 and colon 10. The message here is between colon and colon, and that tells you there are two arguments. There are two words with colons, meaning there are two arguments. So the message here is between and, sent to the object for. 1 max colon 3, object, message, argument. That's the way these things always work in Smalltalk. Receiver object, message, any arguments. So here we have color, R colon, G colon, B colon. So the message is RGB, and you see it's being sent to the class color. Oftentimes you'll see this written like this to separate it out and make it easier to read. That's just a stylistic thing. It doesn't actually mean anything. Now, keyword messages have lower precedence than either unaries or binaries. So in a combination, unaries will operate first, binaries will operate second, and keywords will operate last. When you need to change that, what you want to do is go ahead and use parentheses to break it up differently. We'll get into that in the next couple of screencasts. Now, in the last couple of screencasts, I started mentioning precedence. Today we're going to start taking a look at how that operates. Notice this, 2 plus 3 squared. Now I mentioned that everything operates left-right, but it goes unary, binary, keyword. So the first thing to execute is going to be 3 squared giving us 9, and then you add 2 to get 11. So let's try that out. Do a print it, and sure enough. So 2 raised to 3 plus 2. You should get 3 plus 2 first, then 2 raised to the 5th. So let's see how that works. Print it, and sure enough you get what I expected. So notice, binary first, keyword after that. So here we have a binary, and a keyword. So we should get the point 0 at 0, extent sent to the point with the point 100 at 200 as an argument. So this is the receiver, the message, the object. So we should get this, do a print it, and sure enough that's what we get. So you notice the way this operates. Unaries come first, binaries become second, keywords are executed last, and if you have similar precedence, meaning 2 unaries, 2 binaries, 2 keywords, whatever, it goes left to right. So here we have -3 absolute negated reciprocal. We'll just go straight left to right. -3, we get AVS sent to it, followed by negated sent to that, followed by reciprocal sent to that. So we have it in left-right order. Let's try that out, do a print it, and sure enough that's what we get. So you see exactly how this works. We go left-right, doing unaries, binaries, keywords. Without parentheses, keep in mind keywords are going to come across as one big long message. So if you have multiple keywords, you absolutely need parentheses. Let's go on to the next and see how some of this stuff works. Use parentheses to change the order of evaluation. As I mentioned, 2 plus 3 squared. You want the squared sent to the result of this, so you need to do that. So 5 squared should come out of this. That's what we get. Again, 2 raised to 3. We want this keyword to happen before this binary. Use parentheses. Again, we want this keyword to happen before this unary. So we have parentheses. So you see the way that works. So we'll send that, and that's what we end up with. So if you want to change the default order of precedence, you absolutely need to use parentheses to do it. If you don't include parentheses, it'll go in the order I mentioned before. Left to right, unaries first, binaries second, keywords last. The most common error new Smalltalkers make, and for that matter experienced Smalltalkers make, is to not use parentheses and send keyword messages they didn't expect to send. This morning I'm going to go a little more into depth on something I mentioned a little while ago, and that is that in Smalltalk, given the precedence rules, there's no arithmetic precedence. This is by design. The parser is very simple. The language is very simple. There are a minimal set of rules so that anybody can pick them up and learn how they work without having to even think about it. That does lead to some surprises for people who come from most languages, though. Most people would expect that this would come out with the same answer regardless of what order it is in. So they would think that 2 times 10 plus 2 would come up as the same as 2 plus 2 times 10, because they'd think you'd get 2 times 10 first either way. But you see that we get this here, 22, as expected. But over here we're going to get 2 plus 2 is 4, times 10 we're going to get 40 instead, and that's what we're going to end up with. The reason for that is, again, left, right, at the same level of precedence. So we have binary messages all the way through. We have no arithmetic precedence, so we end up with 2 plus 2 is 4, times 10 is 40. Down here, we want to do arithmetic precedence, so we have to put in the parentheses to get that. So we put parentheses around 2 times 10, and then we add 2, and we get the same answer that we got up here, 22, as expected. So that's something you have to keep in mind in Smalltalk. There's no arithmetic precedence because the precedence rules are extraordinarily simple. Left to right, unary, binary, keyword, parentheses to change that order. And that's really all there is. This morning we're going to take a look at one of the few operators in Smalltalk, the cascade operator. It allows you to send messages back to the same object regardless of what's happened. Normally when we send messages, and I went through this a little bit the other day when we did something like this, 1 plus 2 plus 3, where we just go left, right, 1 plus 2 is 3, then plus 3, so the result of the previous operation is then the receiver of the next operation. Well, sometimes you don't want that. Sometimes you'd like to be able to write this kind of thing without having to write show, 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 and transcript, transcript, transcript over and over and over again. So what you can do is, instead of having the period delimited, and periods are separators in Smalltalk, not terminators, meaning they're not required. At the end of this expression, I don't need a period. If it's the last one, it'll just finish. But a separator separates message sending. Well, down here, this is equivalent to that. Notice what I'm doing here. Transcript show colon hello, and then I have a semicolon. And that says, never mind what came back from the show message. Just send the next thing you see to the original object. Never mind what came back from this show message, send the next message back to the original object. And that's convenient for things like repetitive message sends to the same object. So for instance, if you're putting out some document and you're using streaming protocol, there's a message called next put all to put out text, and you'll have lots of that. Stream, next put all, some text, next put all, more text, next put all, even more text. And it gets very tiresome to put that stream over and over and over again, and this is the kind of thing that allows you to get away with not doing that. So that makes it a lot easier to do, and it's something that you can do with just the semicolon character, which is an operator in Smalltalk. This morning we're going to delve into another piece of Smalltalk syntax, an object called the block, and the literal syntax for creating them. This is how you create a block. I put square brace, code, square brace. Now you're going to notice that nothing seems to happen here. I'm going to do a do it on this, and nothing seems to happen. If I do a print it, I get what looks like the same thing back. That's because what I've done is I've created a block closure object. It's not executed. If I wanted to execute, I would have to send the value or value colon message to it in order to send an argument in. So if I want this to execute, notice I do this, browser open value. It'll now open a Smalltalk browser for me. And this is what got this to execute. What I'm doing with the block is I'm creating a piece of deferred code. I'm taking an execution context, putting it aside, and at some later point I can execute it when I need to. So I can store that execution context in a variable. I can then pass that as an argument to something else. I can store it as an instance variable. I can do whatever I want with it. So if I need to have kind of anonymous functions in Smalltalk, this is how I do it. So here is the same thing but with an argument. Notice this syntax, :x and vertical bar. That means I get exactly one argument into this, and I execute that with value colon and the number of arguments. If I had a 2-argument block, it would be value value. Notice this, :x, :y, vertical bar, the code, and value colon, value colon. So this is how I create anonymous functions, and then at some later point I can execute them. These are highly useful in many contexts in Smalltalk, and this is how they're created as literal syntax. Square braces, code, and then possible number of arguments. This morning we're going to continue with blocks, and we're going to get into another small piece of syntax, the vertical bar variable, vertical bar. This creates what's called a temporary variable. It's temporary to the context we're in. Here it's a little workspace that I'm in, so it's temporary to this workspace context. If I were in a method, which we'll get to later, it would be temporary to that method. And this, even though the syntax looks a little different, :x, vertical bar, that's temporary to the block. So that x is understood only within that block. So any reference to x within this code block is understood only within that block. So here I have a temporary variable b, then b is assigned to the block. So let's just do that part here, and then we'll do b value 12 and see what happens. We'll print that, and we should get what we expect, 14. I passed a 12 in, added 2 to it, and I got 14. So the execution of the block returned whatever object was executed as the last thing. So the last thing was x plus 2. The object that came back from that was 14. That's what comes back from the block. When I execute a block, what will happen is the result of the last message send within the block is the return object. So that's the way blocks normally operate. Of course, you can return early out of a block. I'll probably get to that in a future screencast. For now, just consider the fact that normally, without doing something different, the last execution in a block, whatever comes back from that, will be the return of the block. This morning we're going to get into something that's a little different in Smalltalk, and that is the conditionals and messages like that in Smalltalk are messages. They're not part of the syntax. So in most languages you might have built-in operators like less than and greater than. I mentioned binary messages the other day. This is a binary message, 1 less than 2. And I can send messages like if true, if false as messages to that. So this is just one message sent to this Boolean object. So if I do this printed on just that, I get back a true. So that's a Boolean. And I have if true, 100, if false, 42. So 1 is less than 2, so I should get back the 100. So here's that, if true, if false. And I can reverse that also. It turns out there's an if false, if true, although it's almost never written that way. So I can do this, transcript open. I should get this. So let's put that transcript aside. And then here, 3 greater than 10, if true, do this, if false, do this. Let's try that. And do it instead of a print it. Come over here, no, 3 is less than 10. So that's how that works. And like here, 3 equals 3, if true, we should go to the next lesson. So let's try that. And sure enough. Now, loops. Again, we use block syntax a lot in loops. And again, these are messages, not built-in syntax. So I have 2 : do : is a message sent to 1. So 1 to 100. And by default, it's going to be 1. There is a way of doing this by more messages. There is a way of skipping by 2, by 3, by whatever, by any arbitrary number. We're not going to get into that today. Now, loops. Loops and collection iterators, they're implemented as regular methods. They're not syntax, they're just message sends, which means you can go into the system and find their implementation. If you want to find all the stuff in Smalltalk, you just look in the browser. So it's a little simpler in some ways than most languages. You don't need some huge hairy book of syntax, you can just look at the system. So 1 to 100, this is just iteration. So here I have this, it's going to drop out those numbers, so I'll do it. If I go over here to the transcript, you can see the numbers dropping down, there they are. If I wanted to do by some other number, 1 to 100 by 3, you'll notice the way this is going to work is I can step by other numbers. I could do positive numbers or negative. Notice the way that works. It just flips out the same kind of thing. Notice by -2. 1 to 1 do. This is kind of a silly way of using it, but that's the way these things work. Every collection iterator type method in Smalltalk is a message send to some object. Let's go on to the next lesson here. So do is sent to a collection of objects, an array, a set, any kind of collection object. And here we can do this, do : and we're going to send the object in as the argument. So this is the way you can iterate over a collection and send each individual thing in instead of having to index. So instead of having to index into the collection, I can conveniently have each object come to me. So I can say this collection do each and print them out. So let's just try that and see how that works. And we should just get each element, and sure enough, look down here, that's what we got. There are some other nice iterators that are kind of cool. So here I can take and collect the absolute value of each. This is a way of doing a transform on a collection. So I take a collection, collect : I should get back a collection exactly the same size with the result of this message send right here, the last one in the block. So if I do a printed on that, I get back the absolute value. Notice the -2 became a +2. This is another collection, each odd. So I should get back that a bunch of Booleans on this. So it's going to tell me that one was odd, that one wasn't. Notice the result of the message send gets collected. Now select's a little different. Instead of collecting and doing a transform, we're just going to grab out of it each one that comports to this Boolean. So I have, is each one odd? If it is, throw it in the resulting collection, otherwise don't. So we do this. We should only get the odd elements, and sure enough. Now we have reject. Here we're going to just take the ones that don't pass our test. So we'll try that. So we should get all the ones that are less than 10, and sure enough, all the ones that are less than or equal to 10. So we got that. Notice that we're using greater than instead of greater than or equal to. So that's the way these things work. You can do all kinds of interesting transforms with collect. You can select objects that match a condition, or you can reject the objects that match a condition. And the interesting thing about this is all built into the library. It's not syntax. If you're ever confused over how these work, you just look them up in the system. This morning we're going to take a look at exploring the system, and in Squeak and Pharaoh you can send the explore message to any object. So I can go ahead and do this, and I get an object explorer. Now I can go and drill down to objects, so I can take duration, which is a more complex object, and drill down. But nanos, that piece of duration, is a very simple object, so I can't drill any further. So this is a way of drilling down into an object. So let's take the ProfStef object and try exploring that. We'll do this, and we'll get this object, which is a class. So you notice the ProfStef is a class, so its organization is a little more complicated than the one I just looked at. Now if I wanted to be more cross Smalltalk friendly, I might do something like this: ProfStef inspect, and this is going to work in any Smalltalk, so it's going to give me something similar. So if I do that, I should get an object inspector. And while this object looks a little different, notice that it's laid out kind of the same way. I can drill down still here into objects that are complex and go down, and now it's collecting all the children. So you see it's a fairly complicated one. I probably shouldn't have done that, but in any case you get a very interesting inspector. And over here I have a workspace that has some interesting documentation. It's pulled out the class comment for me. So you can see that in Smalltalk you can get a look at any object pretty simply. In Squeak and Pharaoh there's this interesting explore message, and in any Smalltalk you can always send inspect to an object and get something cool. Now browse will also work across all Smalltalks. I can browse an object and it'll take whatever object I'm looking at. If it's an instance, it'll get the class. If it's a class, it'll get the class. So I can do this, do it, and I will get a browser, and it's collecting all the children, because by doing this I get the class hierarchy browser. And there we go. We have ProfStef. It's looking at this class, and here we have a class browser with